Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
When LSs are going from one area to another area. Remember that DNA bit in virtual link, right? In virtual link, DNA bit will be set onto the database onto the LSS of area 0 only. You people have break for 5 minutes and then after. As we have seen that R4 is having database of area, of area 0, of area 1 as well as area 2. So there is no problem at all. You can see that R5 is having all prefixes available now, right? And also we have seen that virtual link is configured as a demand circuit. That is why there is no dead interval, because it is not sending hello packets anymore because it has suppressed hello packets. That is why there is no dead interval. Now we are having one disadvantage of it. You know what is that disadvantage? We can configure authentication for virtual link as well, right? So now I'm going to teach you that how to configure authentication for virtual link. So router OSPF 1, so you can say area 1 virtual link with what? 4.4.4, and then you can enable authentication. Which type? Authenticate, if you want to enable only plain text, then just press enter here and then allocate authentication key. But if you want to configure MD5, then say message digest and then say area 1 virtual link with 4444 message digest key is 1 MD5 and then Cisco at 123. Now I will show you that neighborship will never go down. However, I configured authentication only on one end. You know why? Because they have already suppressed their hello packets. So that neighbor will never come to know that okay, authentication is getting mismatched. But whenever there will be any update, it will inform to its, because it will send that update to its virtual link neighbor as well.
Yes.
And because authentication is part of all types of packets, whether it is LSR, LSU, LSEC, hello, whatever it is, DBD, authentication is part of all packets. So if there is any change, any change occurs, like if you move on R4 now, show IP OSPF neighbor, there is no problem at all. Neighborship will not go down. But in case if any update occurs, if any update goes through the virtual link, then it will break neighborship. Let me show you. I will simply shut down the loopback of R1. Yes, so that it will give that update via virtual link as well. So once this R4 will receive this update, you will see its dead timer has started now.
Yeah.
So once its dead interval will get expired, you will see that neighborship will go down. But see, they have fixed this problem in new iOS 15. In iOS 15, if you configure authentication only on one side, then after it will activate its dead interval automatically. And it will break neighborship if you do not configure authentication on another end. Are you getting my point? So they have fixed this problem in iOS 15. So now let's move back again on R1, say no shut, this loopback 1, say no shutdown, so that once again it will come up. But this time on R4 virtual link neighborship will not come up without configuring authentication. So do one thing, router OSPF 1. Authentication is message digest, then area 1 virtual link 2.2.2 message digest key 1 MD5. Now your virtual link neighborship must come up. What? It have came up, right? So in this way you can configure authentication for virtual link. Have you understood it or not? But remember that you can also configure your authentication type globally as well. Like if you have said router OSPF1 and then area 0, authentication is what? You know, because virtual link is also part of area 0. So authentication will also get enabled on virtual link as well by configuring this command over here on R2. Is not it? So you must remember the meaning of this command. Are you comfortable with it, Uskin? That how to configure authentication for virtual link and all these things, right? Fine. Apart from it, for virtual link, you can also configure some other things as well, like area 1 virtual link with 4.4.4 hello interval. By default, it is 10 seconds. That interval is by default 40 seconds. You can change it from here. In same manner, that interval. In same manner, you can configure these commands, these all commands, hello interval, dead interval, authentication key, messages, retransmit interval, transmit, delay. All these things can be configured for virtual link neighbors as well. Fine. So in this way, you can change its timers. With time, everything will be performed. Right, so in this way, virtual link will be configured. Even in iOS 15, you can also configure TTL security in virtual link. In iOS 15, you can also configure TTL security in virtual link. Like I know very well that my virtual link neighbor is just 2 hop away from R2. And on R4 also, we know very well that my virtual link neighbor is just 2 hop away. So I will configure my TTL as 2. That if packets are coming after crossing only 2 hops, then only accept them. If packets are coming after crossing more than 2 hops, then do not accept them, because anyone can spoof your packet. Any other device can try to form virtual link neighborship with your device. I mean, attackers can try to form virtual link neighborship. So for security reasons, they have added this new feature in iOS 15. So that you can configure TTL security in virtual link. And the command will be very simple. Like on R2, you can say that area 1 virtual link with 4.4.4 and then TTL security. It's like 2 or whatever it is. However, here it is not going to accept this command because this iOS do not support this command, right? 2 is TTL, 2 hops, number hops. You have to tell that, okay, virtual link neighbor is just 2 hop away from us. So that if TTL is by default 245, so now I must receive packets with TTL value 253. It must receive packets with TTL value 253. If they are coming with TTL value 252, it means someone else have generated these packets. We will not
packet by TTL or TTL is saying that TTL equals to 2 or 3.
How will it be possible? If it is coming with, if you have configured your TTL security as 2, it means it is mandatory to receive your packet with TTL value at least 253. If it is coming with lower than 253, it will drop all those incoming packets. If it is coming with 254, then it will accept it. If it is coming even with 255 itself, then also it can accept it. But if it is coming with 252, then it cannot accept all those packets. This feature is taken from BGP itself actually. In BGP, we were already having this feature TTL security for neighborship, right?
So we can try
But they have taken it from here.
Yeah, we can try this using 7.0.
But the thing is, even here also it is not supported. I think so. I'm using 12 point. I mean, I'm having 15.2, but it is in 15.3. Like cryptographic authentication is not supported by 15.2 itself. It will be supported by 15.3, 4, or 15.5. Right? So in this way, you can do all this type of configuration. Fine. So I hope that now all of you have understood the uses of virtual link. That is why I always said that ABR must have very good hardware configuration. See, now R4 is handling the database of area 0, entire database of area 0, entire database of area 1, entire database of area 2. Are you okay with it?
Yes.
Fine. After it, let's do one thing. Let me tell you fast hello interval in OSPF. Like we can change its timers, but we are also having one another option here on R1. Like we can do this configuration as well. Serial 1 by 0, IP OSPF dead interval minimal. If you configure this command dead interval minimal, its dead interval will be configured now as 1 second. The meaning by minimal is what? 1 second. Hello?
Yeah.
The meaning of this command IP OSPF dead interval minimal is what? 1 second. And then you have to tell about your hello multiplier. If you says that hello multiplier is five,
Okay, within 1 second, you can send 5.
right? You see, what is it saying? Number of hellos sent within 1 second. So I have said 5. After configuring this command, you will see that your neighborship will go down because timers will get mismatched.
But convergence will be fast.
Yes. Show IP OSPF neighbor. See, it will break its neighborship, but after some time, you see, it has reached 15 seconds now. 11 seconds, because 11 seconds, 11,000 milliseconds. 9,000, 6,000 means 6 seconds. 3 seconds. Gone. In same manner, you have to move on R2 on its serial 1 by 0, say IP OSPF. Hello interval is what? Sorry, dead interval is what? Minimal. Hello multiplier is what?
5 seconds.
This time you will see that neighborship will come up.
Hello multiplied for 5 weeks. It will send 5 hello.
What?
Hello multiplied 5 weeks.
It will send 5 hellos in 1 second.
5 hello.
Right?
It will be faster than EIGR.
Of course. But SPF algorithm, another some global timers are also there, right? Some global timers are also there, so we cannot say that now it have become faster. I mean, its convergence have become faster than EICRP. We can't say. Understood? So now I have finished all basic practicals of OSPF, like how to change cost of the interfaces, how to manipulate your auto cost reference bandwidth, how to change your cost per neighbor, how to modify your network types, what are the differences between them, how to define a static neighbor, how to configure virtual link, how does it really work. And even I said that virtual link is configured as a demand circuit. You can also configure a normal interface as a demand circuit as well. Like, let's say I want to configure in between R5 and R6. I don't want to send R5 and R6 to, I don't want to let R5 and R6 to send hello packets to each other, right? So you do one thing, move on R6 and go to its serial 1 by 0, because you know very well that R6 is connected with, tell me, with R5 on its, with using serial 1 by 0. So you say IP OSPF is what? Demand circuit. Just configure this command. And it's not mandatory to configure it on both sides. Just configure it only on one end. Now, both routers will negotiate that, okay, this link is configured as a demand circuit. Now, what will happen that they will not send hello packets to each other. And also, whenever this R6 will receive an ELSA via this link, DNA bit will be set onto it. Show IP OSPF neighbor. Is there any dead interval now? Show IP OSPF interface on the serial 1 by 0. Hellos have been suppressed because it is configured as a demand circuit, right? Now you can check show IP OSPF database as well. Still it is not showing you DNA bit, but if you say clear IP OSPF process, now it will start to show you DNA bit as well. Show IP OSPF database. Check it out. On all LSAs, whether it is router LSA or summary LSA, because all of them are coming through this demand circuit. That is why DNA bit has been set onto them. So that now R6 will never ask to these devices to retransmit their LSAs after every 30 minutes periodically. Hello. This is called demand circuit, and that is why I said that by default virtual link is configured as a demand circuit. Yes.
And what is the IP you use on multicast
For what?
in this demand circuit?
Of course, they will be using here. It's not virtual links, so I mean, they will send only multicast, but only once, right?
Yeah.
They will send hello packets. They will send multicast hello packets till neighborship comes up. Once neighborship will come up, it will stop. I mean, they will stop to send hello packets to each other. When you do one thing, you can capture this link as well. Any problem? Are you okay with it?
So, when you say that demand circuits suppress the load and there is no 30-minute separation interval.
Exactly.
So what happens when that interval comes?
And-
This circuit doesn't forwards that.
Information. Huh? If there is any change, it will generate incremental update. You understand? It does not stop those incremental updates. It is stopping only and only periodic updates.
It's a periodic update of 30 minutes. So say for example, if this topology router 4 does a 30-minute refresh,
Yes.
and then that update reaches router 5.
Yes.
Router 5 will suppress that and not forward it to router 6.
Exactly. It's not like that R5 is not gonna to send it towards R6. See, if R5 receives any update coming from R4, there is no DNA bit except this LSA. So even if this R5 will ask to all these devices to regenerate their LSAs, because these LSAs are not coming through the demand circuit now, because the link in between R4 and R5 is not configured as a demand circuit. So once R5 will receive any update, definitely it will advertise it in the direction of R6. But R6 will never ask to anyone to refresh LSAs after 30 minutes.
Okay, so this periodic refresh is like request.
Exactly. First of all, you have to generate a request, right? Like on R6, if timer has expired, 30 minutes have expired, then R6 will generate a request that okay, I want these updates, I want these LSAs once again. Just to check consistency of your database, that whether all devices are having common database or not. Yes.
So request to generate to
Why?
maybe
It will not. I mean, the thing is, it will not require to generate a request by a device. You know why? Because timer is same even on that device too, which have generated that LSA itself. So whenever that 30 minutes will get expired, even that source router will regenerate those LSAs after 30 minutes automatically. That is why other devices will not require to generate.
तो फिर अगर रिक्वेस्ट फेज नहीं होगी तो फिर वो तो अपना रिफ्रेश इंटरवल को जनरेट करेगा.
Exactly.
फिर डिमांड सर्किट जहाँ से स्टार्ट हो रहा है वही सप्रेस कर देगा ना अगर रिक्वेस्ट फेज नहीं होगी.
रिक्वेस्ट कहाँ से भेज रहे हो?
समझो R6 और R4 का टाइमर.
मैं यही कह रहा हूँ कि R6 पे ना अब ये DNA लग गया तो मतलब ये ऐसे ही रहेगा as it is. It will always keep this as it is. 142 will never get expired. But in case if any change occurs on any other device, it will immediately inform to R6.
So this option is widely used, right? I mean, because
One more thing, if R6 is never gonna to ask to any other device to retransmit these updates after 30 minutes. That is also another thing. However, the source like R4 Like for an example, if R5 is there, R5 will definitely ask to R4 to retransmit updates after 30 minutes. So in that case, R4 have to generate those LSAs after 30 minutes. Even like for an example, if you move on R4, show IP OSPF database, check the database table of area 2. So DNA is there because it's a part of LSA itself. So this router, this device R4 is not gonna to ask to R6 to regenerate this LSA after 30 minutes. So no one will ask, no one in this area, in this entire area 2, no one will ask to R6 to generate
दोनों साइड पे कंपेयर करोगे ना, और रिक्वेस्ट भी रेज नहीं करेगा, वो बोलेगा.
exactly. And it is not expected now for this device. See, just try to think in perspective of R4. R4 has received this LSA. Now R4 will not expect from R6 to receive this LSA after 30 minutes once again, because DNA bit is set. Are you getting my point or not? So in case previously, what was happening, that if you do not receive LSA information up till 1 hour, it will remove that LSA from its database table. But this time, because DNA bit is set, so that it is not gonna to remove this LSA from its database table. I hope that now you have completely understood it. So if you have received any LSA with the DNA bit, then it will never ask, or it will never expect from its advertising router to regenerate those LSAs after every 30 minutes. So I hope that virtual link and this demand circuit is perfect now to all of you. And apart from this demand circuit, we are also having another feature. See, the problem of demand circuit is, like, if I configure authentication now, they will not break neighborship. I get my point? Means they have also suppressed their hello packets. But what I just want to stop periodic updates of OSPF. I do not want to suppress hello packets. I don't want to suppress hello packets, but I wanna disable periodic updates in OSPF. For that purpose, you are having a feature in OSPF which is known as flood reduction. Flood reduction. You just wanted to reduce flooding of database in OSPF. Periodic flooding, is not it? So if you want to reduce periodic flooding in OSPF, then you can use flood reduction. Let me show you. I'm on R6 now, on its S1/0. I will say no, or you say IP OSPF demand circuit. Demand circuit, just remove it, and now you will see that again it will start its dead interval. See, and then there will not be any DNA bit now. Do one thing, say clear IP OSPF process. Fine. So you will see that there will not be any DNA bit now. Is there? Nothing. Understood? Fine. But this time I'll configure flood reduction in same manner. Go to under interface mode, serial 1/0. You cannot enable these commands globally. You have to configure this command under interface mode itself, right? So now, because we are having one neighbor onto this interface, so I'll say IP OSPF flood reduction. Once you will configure this command, now you are not required to configure it on both sides, right? After configuring this command only on one side, see show IP OSPF neighbor. See, that interval is still there. It means you have not suppressed hello packets. It have not suppressed hello packets. But if you see show IP OSPF database, you will see that DNA bit is set over there. Clear IP OSPF process. Just wait for a moment. Oh, here you will get that actually. because I just configured flood reduction at the end of R6 only. So whenever R6 will advertise its router LSA towards R5, it will advertise it with DNA bit. So in this case, I have to move on R5 as well. On R5 as 1 by 0, I have to say IP OSPF flood reduction. Once you will configure this command at the end of R5, so whenever R5 will advertise any LSA in the direction of R6, it will add DNA bit onto them. Say clear. IP OSPF. Oh, I think I configured it on wrong interface on R5. Configure it on S1 by 1. Move on R6 now. And you see show IP OSPF database. So this is also another feature of OSPF, flood reduction. मैंने कब कहा बिल्कुल बंद हो जाएगा? Its name is itself flood reduction. You are reducing the flooding of OSPF LSAs. Because now it will never, I mean, these LSAs will never get expired here on R6. Even if they have broken their neighborship, let's say, let me show you. Serial 1 by 0 on R6, I have shut it down. So it will break its neighborship, but still it will keep. And previously what was happening that after 60 seconds it was removing all those LSs, but this time it's not gonna to remove them.
डीएनए वाले को तो वैसे भी नहीं वो रिमूव करेगा।
हाँ तो वही तो बता रहा हूँ कि डीएनए कब आया? जब फ्लड रिडक्शन कॉन्फ़िगर किया. Have you understood it? Now it's not gonna to remove all these LSs from its database table forever.
अगर हम लोग जैसे ट्रिगर्ड अपडेट अगर हो जाता है उसमें कोई इंटरफेस डाउन होता है तो रिमूव कर देगा.
Of course. See, you are not reducing your triggered update. This is all about the flooding. We are talking about, I mean, demand circuit, and this flood reduction is all about your periodic updates. Once again, neighborship will come up, so that it will not require to ask to its neighbor to retransmit those LSAs once again, right? Because it is already having those LSAs available inside its own database table. Fine. So in this way, flood reduction will work in OSPF.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.